Hey guys, Mr. Ray again, with another type of quadratic word problem that we're going to look at. This one is not that common in terms of number of questions. It has to do with structures. So this will be structures that are in the shape of a parabola. Most of the time it'll be a structure that, opens down like an arch, okay? Like a bridge or just a arch structure. So I just created this problem. So it's not from your booklet of word problems, but it's a pretty good question. Um, so we got here the St. Louis Gateway Arch is a parabolic structure, and this is actually the right numbers. I looked it up. It's 630 feet tall and 630 feet wide at the ground. So where it touches the ground, it's 630 feet between. So the question is, what is the height 100 feet from the center? So this is an ideal situation to draw a little graph of what's going on. So this arch, now I could draw the arch, over here or over here, but I find the best way to do it is draw it so that the vertex, the maximum height, is right along the y-axis. So if I know that point is 630, then if I know the height is 630, I know that point would be 0, 630, and that's the vertex. So I'll keep with the x and y here. Doesn't really matter. So that tells me the maximum height. The other part is that it's 630 meters. 630 feet wide. Now, since I've drawn it this way, that means, it's basically going to be 630 that's centered at the y-axis. So that means half of that distance will be on this side and half will be on this side. So if I draw that, this point here would be, this would be my positive 315 because that's half of 630, and this would be negative 315. Okay, so if you take the distance, 315 to there, another 315 to there, that's 630. These are like my x-intercepts. So when I draw my arch, let me do that side again. So the arch looks something like that. Okay, so the question is saying, what is the height 100 feet from the center? So that means 100 feet from the center, well, it could be that way or that way, 100 feet. Now, it doesn't really matter. This is symmetrical. So, whichever way I go. So if I say that's at 100, I'd like to know, what is the height there? Now, the problem here is, obviously, I don't have an equation. So, and this goes, hopefully this should be pretty straightforward. We've got the vertex and the x-intercepts, and we have several options on how to build this equation. You could start with the vertex, build the vertex form. From the vertex, add one of these 2 points, or you could put in the 2 x-intercepts in your factored form and then add the vertex as your additional point. You'll get 2 different looking equations. One will be vertex form, one will be factored form, but if you're to use it, you should get the exact same answer. So I am going to, well, let's just summarize here. So our xh, which is our vertex, not xh, hk, our hk value is 0, 630. And in terms of the, the x-intercepts, I've got negative 315, 0, and positive 315, 0. These are my x-intercepts. Okay, so I could, like I said, we could either start with this, build our equation in vertex form, or start with this, build our equation in factored form. I'm going to do the vertex just because that's what I feel like. So y equals a x minus h is 0, squared, plus k is 630. So now you don't see this all that often. X minus 0 is just the same as x, right? So I'm just going to simplify that. Ax squared plus 630. Now, we still have to find the value of a, and since we've already used that point, we have to use one of these 2 points, and it doesn't matter which one. I'm going to sub in that one just because it's positive. So I'm going to sub in 315, 0. So that's my x, that's my y. So y is 0, a times 315 squared plus 630. Okay, well, I'm gonna want to isolate my a, so I can subtract 630 from both sides right away. And then when I square the 315, I'm going to get a pretty big number, 99225a. And when I divide both sides by 99225, I get a is equal to negative 630 over 99225. So that's a pretty ugly looking fraction, but you can actually reduce it. The first thing you can see here easily is it divides by 5, and then you can see they both divide by 3 twice again. So this actually reduces to something a little nicer to look at, negative 14 over 2205. Okay, so that's our a value. Now you could, that's a pretty small decimal. I think it's like 0.0006, something like that. It's so in this case, I'd prefer to leave it like that. This is exact, right? So let's leave it like that. So now when we create our full equation, I'm going to go back to this and just replace a with this fraction. Negative 14 over 2205 x squared plus 630. So that is the equation for this parabola. Okay, I can get any point along here by using this equation. Okay, you can just see if I plugged in 0, right, that this turns to 0, the whole thing turns to 0, y would be 630. That makes sense. Okay, what we want to do now is use this equation. We want to set x equal to 100, or we could have done negative 100 because that's 100 meters to the left. We'll get the same answer. So y equals negative 14 over 2205 times 100 squared plus 630. Okay, so I'm just going to go to the final answer here. Final answer is 566.5, and the units are feet. Okay, and it's always good to do a little sanity check on your answer. See if you're in the ballpark, see if it makes sense. So does it make sense that that's 566 feet high? Sure. It's definitely below 630, but it's not too far below. So that seems like a reasonable answer. So I'm going to go with that and do a word answer. Therefore, the St. Louis Arch is 566.5 feet tall, 100 feet from the center. Okay, so you could tell, now I didn't really say this, but the word parabolic, you can see the word parabola in there. It means the structure is a parabola shape. So anytime you get a structure problem, you'll see that word, or they might even give you the equation of what the structure is, and it'll be a quadratic equation. So in this case, we actually created the equation knowing the vertex and the x-intercepts, and then used the equation to find a specific point that they asked for. Okay, so that one, you should have been able to do this part from before we did word problems, create the equation from this information, and the word problem is just using the using the equation to find a point. Okay, hope that helps.